Hello everyone, in this video I'm going to walk you through this question Q4b, the question, one of the questions from part 1 of the RF microwave homework assignments. And you are given the low impedance 80 minus 360 and the characteristic impedance of the transmission line is based on 50 ohm. So we are going to match this low impedance to 50 ohm. Remember, um, in this kind of person, most likely you will end up with more than one solutions. Okay, so I'm going to stop the screen sharing and I will direct you to the Smith chart. So this is my Smith chart. Okay, so to start with, you are given the low impedance 80 minus 360, and after normalizing the low impedance to 50 ohm, you got 1.6 minus J 1.2. So your first job is to locate the uh, the point where the normalized low impedance is. So here is 1.6 and minus 1.2 is here. So you just draw the locus and minus 1.2. So this is your low impedance, the location of the low impedance. Now, what you are going to do is to join the origin. Use a straight line to join the location where the low impedance is, and the origin of the Smith chart, and then draw a constant SWR circle. So I got this. Okay. Yeah. Very good. Okay, done. So this is the constant SWR circle. So these are just garbage. Okay. The next thing that you are going to do is to drag along the constant SWR circle. No, the next thing that you are going to do is to draw a straight line connecting O and A. So O and A. And then write down the angle of the refraction coefficient. So right from here, from what I can see here, I got 0.3 0.4 lambda. And then you drag along the constant SWR circle until you meet with the intersection point, until you meet the intersection point where the 1 plus JB circle meets. So this is 1 plus JB circle. This one. So I got one point here and another point here. So let's label this B, and this one is B palm. So you have two solutions. Your first task is to determine the location where the stop is to be mounted. The open circuit stop is to be mounted. So you have the two locations. One is B, the other is B palm. So let's try B first. So if you, based on this solution, and you need to draw this line joining O and B, and then look for the length here. So for what I can get here, I got 0.414 lambda, while here I got 0.304 lambda. So in other words, the location of the stop can be found by the angle here. So 0.4 minus 0.304, and I get 0.110 lambda. So this will be the length of the transmission line. So I'm going to draw my solution here. So suppose this is the transmission line 50 ohm, and the length here is 0.11 lambda, and the load here is 1.6 J minus J 1.2. So this is the first part of the answer to the questions. The second part is to determine the length of the open circuit stop. So the length can be calculated according to the track here. Now, when you drag along the constant SWR circle, you meet with the intersection point where 1 plus JB circle and the constant SWR circle meets. So at this point, you will have the impedance, admittance, 1 minus about actually 1 plus about 105. So what you need to do is you use another point to cancel off this surplus subsectant. So the point that you look for is here, B palm. So if you look at here, so this is the amount of subsectant you need to cancel off. You need for canceling off this amount. You are going to use transmission line to do it. So I'm going to show you. So you will do this until you reach the outermost circle. So what I get here is 0.12 lambda, but this is the value, the length of the short circuit stop. So this is the length of the short circuit stop. But the question asks for open circuit stop. Open circuit stop should be count from this end, not from this end. So you count all the way uh, from the right hand side until in the clockwise direction until you meet this one. So what you get is 0.125 plus 0.25. So what I get here is 0.37 lambda. So in other words, the length of the stop, open circuit stop that you need will be 0.37 lambda. So this is your maximum level. But this is just one option. There is another option as well. So instead of dragging from point A to point B, you can continue to drag non-stop until you meet B palm. So at B palm, you need to find the location of the stop by counting from this position here all the way to B palm. So you need to find the angle. The angle is so what I need to do is we need to draw a line here. Then so this is what you need. So from what I can get here, I have got 0.0 A 4 lambda. So you need to you're counting from this point until you reach here. The length will be 0. Um, let me check. So you are going to calculate the whole length here. 0.2 0. So 0. Yeah, it's about 0.282 lambda. And now you're going to find the open circuit stop that cancel off the surface subsectant at this point. So you need to look for point B here. And from point B here, you get so this is your length. Your length here is about Counting from 0. Um, the length here is is about 0.129, 0.1299. So 0.1299. So what you need is another matching network. 1.6 minus J 1.2, and the total length here is 0.282 lambda. The open circuit stop that you require according to my estimation, counting from this point, this one is 0.25, while this one is 0.38. So 0.13 lambda. So the length here will be 0.13 lambda. So you have two solutions. One is this solution, the other is this solution. Okay, both will work. Thank you.